Okay, so angles and polygons. So first of all, we want to ask, what is a polygon? Well, a polygon is just a shape. So a triangle is a polygon. Let's zoom in a bit. I've obviously made this frame really large without realizing. So this is a polygon. I'm going to color these in just because they'll be easier to see. Yeah, and we'll get a square. We'll make them just all yellow. I think they don't need to change. They need to be different colors. And then we have we can also have a pentagon, and let's just do a hexagon, and that'll do for now. Now, what I want you to realize about this is that all of these shapes, they start off with 3 sides, 4 sides, 5 sides, and then 6 sides. And if we wanted to, we could keep going up to 7 sides, 8 sides, and so on and so forth. And they all have names as well, but we're just going to look at these 4 as examples. They've got 4 sides, and they've got 4 angles inside the shape. Okay, so now we know a little bit about the triangle and square already. So these are the inside angles. This particular triangle has got equal length sides, and it actually has equal angles as well. So I'm just going to do that. I'm going to demonstrate that by just colouring in the angles a particular colour. Now, one of the other things you may be aware of is that all angles in a triangle must add up to 180 degrees. Now, this is not something that you need to know for this topic, but you may remember it from learning about triangles. It might have come up with something else that you learnt about. So let's just make a note of that. All angles in all triangles, add up to 180. I'm just going to write the word degrees for now, rather than finding the symbol somewhere. Now, because of that, this type of triangle, as I said, is one that has equal angles and equal sides. So we can call this type of triangle an equilateral triangle. Okay, equilateral. And why is it called equilateral? Well, equi means like equal, like the same, and then lateral, that's referring to the sides. So it just means all the sides are the same. So this is an equilateral triangle. And all these shapes, in fact, they all have equal length sides and equal angles. So this square, a square is, well, I was going to say a square is like a rectangle. A square is a rectangle, but it's a regular rectangle in that all the lengths are the same and all the angles are the same. In fact, this is a 4-sided shape is called a quadrilateral, and that means quad there, lateral, 4-sided, lateral means sides, right? This is a regular 4-sided shape, which we call a square, of course. Okay, so we give these regular shapes special names. So let's just make let's give it a definition of regular. Regular shapes have equal length, sides, and equal angles. We can refer to the angles that I'm talking about there as internal angles. I'm going to put internal in brackets, actually, because generally speaking we don't use the word internal in that way. If I say angles in a triangle, I think everybody knows what angles I'm talking about. So we don't usually use the word internal. you may know that this one is called a pentagon. Pentagon. And that this one is a hexagon. So they all have equal length sides and equal angles. Now all of these are polygons because polygons just means shape. Okay, so let's define that as well. So polygon, I want to give it a white background. So polygon just means shape. And these are regular shapes or regular polygons because they have all equal length, size, equal angles. We are going to be eventually in this topic looking at non-regular polygons, or otherwise known as irregular polygons. But to start off with, we're going to look at regular polygons. Now there is a way to work out the angles of all of these polygons, and we know that in an equilateral triangle, and all triangles add up to 180 degrees, if all of them are the same, then whatever the size of this angle is, 3 times that must be 180. So to work out the size of this angle, we just take the 180 and divide it by 3, and we get 60. So the angle in an equilateral triangle is 60 degrees. They're all 60 degrees. And you probably already know, I'm sure you already know, that the angle in a square is a right angle. So I'm just going to do the right angle symbol this time. So what about the angles in the pentagon and the hexagon? You're less likely to know this, but what we can do is you can start to notice a pattern with the two that we do that we are already aware of. So I'm going to take these, make copies of them, and look at them a bit more closely. So I use the phrase internal angle. So, and that would be the opposite of external angle, wouldn't it? So let's think, what could an external angle be? Basically, if I were to take the line and extend it outwards like that, and probably also make it a dotted line, the external angle is this one here. Okay, so that's as you can see, it's outside the shape. So we can do that with we can do that anywhere. It doesn't really matter if I did it like that or if I did it like that. I get the same answer. Okay, I get the same value. So let's just write them all. I'll do them this way, so it kind of like moves like almost clockwise in a way, if you know what I mean. It looks a bit more neat and tidy, but it doesn't really matter if you did it the other way. So these are the external angles. This is the external angle. Now I'm just going to pause the video there, and I just want you to tell me what is the value of the external angle for the triangle, equilateral triangle, and also for the square, and you send me that in the Zoom chat. Okay, so hopefully you've got the external angle as equaling 120 degrees, and the hint I would have given you, or nobody asked for a hint in the end, is that this, I would have just said straight line, because that is a straight line, and so we've got 60 plus whatever that is must add up to 180, and so the external angle is 120 degrees. Now we're going to use symbols for external angle and internal angle. We're going to use the letter E for external angle, and we're going to use the letter I for internal angle. I didn't, haven't looked at the square yet, but we'll see that. And we're going to explicitly note that E plus I is actually always going to equal 180 degrees because of kind of the definition of what an exterior and interior angle is. And as I think you've all written, the exterior angle of a square is also going to be 90 degrees. So so we're going to just identify that, and your next question, which is a bit harder than the last question, is going to be, what pattern do you notice about the exterior angle and of the triangle and the exterior angle of the square? Now, if you happen to already know this because you've done some self-learning, don't worry. But if you think you're like, oh, I already know this one, I don't have to work it out. But either way, if you have to work it out, write it down. If you already know it, write it down. So what do you notice with regard to the exterior angle of the triangle and of the square that they both have in common? Okay, I'll let you have a think about that, see if you can work it out. I'll pause the video. Okay, as one of you have managed to work out that if you were to add up the external angles of this triangle, you're going to get 120 times 3, which is 360. If you did the same for the rectangle, for the square, you will also get 360. Okay, so this is the rule. This is the important rule that we're going to notice, that the sum of the external angles add up to 360 degrees. And this is the key, the thing here for all polygons. Now, I've only shown it's true for this square and the triangle, but it's also true for all polygons, and it's also true for regular and irregular. So if I were to make these irregular quadrilaterals and irregular triangles, the exterior angles would still actually add up to 360 degrees. Okay, so I mentioned that briefly because for you, actually, let me just pause the video here. So let's have a look at some of these other shapes, and your next task is to see if you can calculate the external and internal angles of the regular pentagon and the regular hexagon. Okay, I'll pause the video while you have a go at that. Right, so if we know that with these two shapes the sum of the exterior angles must still add up to 360 degrees, then we look to see how many exterior angles there would be. Well, here's one, there's going to be another one there, and so on. There's going to be 5 exterior angles. So if we start off by just labeling that exterior angle as E, because that's the symbol for the exterior angle, the internal angle would be I. And there are 5 exterior angles, so we can say that 5 times E is going to be equal to 360 degrees. And then we just rearrange the equation by dividing both sides by 5, and we have E is equal to 360 degrees divided by 5. And on my calculator I get 72 degrees. So E is equal to 72 degrees, and we know that the E plus I must be equal to 180 degrees. They have to, we can see they're on a straight line there. So I is going to be equal to 180 degrees minus 72 degrees, which is going to give me 108 degrees. And this is a regular shape, so all of the internal angles are going to be equal to 108. Okay. So similarly with the hexagon, I'm just going to pause the video for a moment. Okay, so we've got the hexagon. Let's just neaten that up a bit. Yeah. So once again, the we would label that angle as E and that angle as I. We know that we can see very easily that they both add up to 180 degrees. And this time we would see that 6 times E is going to equal to 360 degrees. And so dividing both sides by 6, E is going to equal to 60 degrees. I've divided 360 by 6 that time. Then I is going to be equal to 180 minus 60, which would be 120 degrees. So you don't have to memorize this, but you just need to know how to apply it like we did here. So lastly, I'm going to have a look at how we can come up with a formula for just the interior angle given what we know about those two different formulae. So we've got our first formula, which we learnt is that I plus E is equal to 180 degrees, and we've got a second formula, and I need to introduce a new variable now because it depends on the shape, doesn't it? So how many sides does a shape have? The amount of sides I'll call n. So we know I is the internal angle, E is the external angle, and we'll say n is the number of sides. So if I were to, maybe let's use a highlighter, then that would be 6 in this case and 5 in this case. So we can say that n times E is equal to 360 degrees. So we can actually combine these equations. So with the first equation, I can rearrange it by minusing I from both sides. And then I have what E is. I got E as the subject. And I have E is equal to 180 degrees minus I. And this one here, maybe I'll use some colour this time, make it a bit easier to follow. So if we do all equation 1 in blue, I'll do equation 2 in pink, then I can rearrange, I can put equation 1 into equation 2 essentially. This bit's a bit more advanced, so even if you don't follow all of this, it's okay because you can just do it the way that we just did it earlier on. But if you can follow this, then it's going to make things a little bit easier for you. So instead of doing n times E, in place of E, I'm going to write what E is equal to, which is 180 minus I. And then I'm just going to put that in brackets. And I'm going to say that's equal to 360 degrees. So I might sort of tidy this up a little bit now, because what I'd like to do is make I the subject. So now we're doing a bit of algebra inside our geometry topic, but we're going to expand. I'm not sure if you've done expanding before. Just nod if you've done expanding before. You have. I had a feeling you had. Okay. So when we expand, this is single bracket expansion. There is double brackets expansion. That's harder, but this is a bit easier than that. I'm going to multiply the n by the 180, and I'm also going to multiply the n by the I. So I end up with 180 n. I'm not going to bother with the degree symbol here. And then I'm going to minus I times n. So in. Oh no, I didn't. That's not what I want to do. I just remembered. I don't want to expand. Change my mind. Sorry. I want to make I the subject. So that wouldn't be a good idea. That would just, yeah, that would be not particularly useful. Instead, what I'm going to do, I'm going to divide both sides by n. So I end up with this. I don't need the brackets anymore because it's not being multiplied by anything, because the n's going to go away, and it's going to be 360 degrees divided by n. So on the left side I divided by n, which meant the n went away and therefore the brackets are no longer needed. And then on the right hand side I just divided it by n. Next I'm going to subtract 180 degrees. Now a lot of people make this mistake and they think that when I subtract 180 degrees I end up with I on the left hand side. Okay, let's just group that. But I don't. I actually end up with negative I, because essentially what we've got here on the left hand side is 180 plus negative I, in a way. Okay, it's the same as saying take away I. So I get negative I when I subtract 180 degrees. And that's going to be equal to the right hand side, and then of course minusing the 180 degrees. Like that. So now it's a bit messy to make negative I the subject. So we want to multiply both sides by -1, and when we do, on the left hand side we will just get I, which is what we want. Now I is the subject. What do we get on the right hand side when we multiply both sides by -1? Well, this whole thing would become negative 360 degrees over n, and this thing would be negative 180. When you take away a negative, you get a positive, so you'd actually end up with negative 360 degrees over n plus 180. Okay, let me just say that again. It would be negative 360 degrees over n, then plus 180. So that could be rewritten as just 180 take away this. So let me just go over that bit a little bit more carefully. Essentially, I had something like, let's call it A, minus something else, let's call it B. I multiplied it all by -1. Now that gave me negative, it's like this. And that's just the same as flipping it around, isn't it? So what we've learned there is that whenever you have something minus something and you multiply it by -1, you can just flip them around. So that's a quite useful little trick, a little pattern to notice. Okay. Whoa, oh, I just messed that up. Let's group it there. So we end up with this equation here. Now you could, if you wanted to, sometimes you see in textbooks this written slightly differently. What we can do, if we can now factorize. Can you nod if you've done factorizing before? You have done factorizing, okay. So, so I'm going to show you how to factorize this. I'm going to take out a factor of 180. Like that. And I can't remember the different formats, but you could do this. And then I'm going to make that 1. So that 180 divided by 180 is obviously just 1. Then over, and then 360 over n, that's going to become 2 over n. So you might see something like that perhaps. Okay, so you've got, I think I'm going to just make a square here. Let's give that a white background and we'll send it to the back. So that is quite a useful equation. for internal angles. Right, let's see. Yeah, they move together now. Okay. And we'll do another one there. Okay. Right, so that's quite a useful equation, and what we'll also do is get some of our other equations down here, and we'll put them in boxes too. Whoops. Okay, I'll do that off video. We don't need to video me doing this. I will stop the video there.